Hello everyone, my name is Nam. This project explores Japan's birth statistics through a glyph visualization that highlights gender trends, birth rates, and infant mortality over time. I applied key ideas from Edward Tufte and Colin Ware to turn complex numbers into a clear, visual story. The data for this project comes from national birth records in Japan, covering the years 1947 to 2022. It includes 4 key variables: the total birth rate per year, the number of boys born, the number of girls born, and the infant mortality rate. I chose this dataset because it offers both simple totals and deeper insights when you compare gender differences and health outcomes across time. The link to the dataset is provided here, and the information has been cleaned and organized to support clear, meaningful visual patterns in the final design. Working with these multiple variables allowed me to create a richer visualization that could highlight important social and historical changes over time. Before building the final visualization, I first created a simple line graph following Edward Tufte's design principles. This graph shows the total number of births per 1,000 people each year from 1947 to 2022. Following Tufte's theory about maximizing the data-ink ratio, I kept the design clean, removing any unnecessary decorations, colors, or chart junk that might distract from the core message. You can see a clear spike in the early 1950s, which represents Japan's post-World War II baby boom. After that, there is a steady and continuous decline over the decades, reflecting changes in family structure, economy, and society. This line graph serves as a foundation, a simple but powerful way to introduce the broader trends before moving into the more detailed, multivariable visualization. This visualization is the centerpiece of my project, and it brings Colin Ware's theories into action. Each X you see represents 1 year, but it carries multiple layers of information through visual features. First, the color of the X shows the gender balance. If the X is blue, it means more boys were born that year. If it is pink, it means more girls. If it turns purple, it signals that the number of boys and girls born was nearly equal. When you scan the graph, you notice immediately that almost all of the X's are blue. That tells us at a glance, without reading any numbers, that boys have consistently been born at a slightly higher rate every year. The size of each X represents the total number of births. Larger X's mean more babies were born that year. You can clearly see that the largest X's cluster around the early 1950s, right after World War II, marking Japan's baby boom period. This pattern visually confirms historical events without needing any written explanation. The third variable is shown through the color gradient from red to green. Red represents a higher infant mortality rate, while green represents a lower one. As time moves forward, the X's shift from reddish shades to greener shades, showing a steady improvement in healthcare, living standards, and infant survival over time. This entire approach is based on Colin Ware's principles of pre-attentive processing. By using intuitive visual features like color, size, and spatial arrangement, the brain picks up major trends instantly, without needing to analyze each point manually. The viewer can immediately see gender imbalance, population surges, and healthcare progress, just through natural perception. The design turns complex, multidimensional data into a story that people can absorb quickly and clearly, which is exactly the goal of effective data visualization.